Have you ever wondered why we eat? It's not just because pizza tastes awesome or because ice cream is a super cool treat on a hot day. We eat because our bodies are incredible, high-tech machines, and just like any machine, they need fuel to run. Food is that fuel. It gives us the energy to run around the playground, to think hard in science class, and even to dream at night. Every single thing you do, from blinking your eyes to kicking a soccer ball, requires energy. And where does that energy come from? You guessed it. It comes from the amazing journey your food takes through a winding, wonderful system inside you called the digestive system. Consider this. Science is all around us, and it's even inside us, working hard every second of every day. So, let's embark on an epic journey together. We're going to follow a piece of food, let's say a delicious bite of an apple as it travels through your body. This isn't just a simple trip, it's a transformation. It's a science experiment that happens every time you have a meal. Your body is like the most advanced laboratory in the world, equipped with powerful crushers, chemical mixers, and super absorbent tunnels. It's designed to break down that apple or that sandwich or that bowl of spaghetti into tiny usable pieces. These pieces are the building blocks and the power source for everything that makes you, well, you. So, buckle up, because our fantastic food voyage is about to begin. It's a tale of chemistry, biology, and pure mechanical wonder. Think of your digestive system as a long, winding tube that starts at your mouth and ends. Well, you know where it ends. This tube is called the alimentary canal, which is a fancy science way of saying food tube. Along this journey, our apple will meet several amazing organs, each with a very specific and very important job. It's like a team of superheroes working together. Our food's grand adventure starts in the mouth. The moment that bite of apple enters, your mouth springs into action. It's not just a waiting room, it's the first and very important stage of our digestive factory. Your teeth are the first tools on the assembly line. They are incredibly strong and designed for specific jobs. Your front teeth, the incisors, are sharp, perfect for biting and cutting. Then your pointy canine teeth help tear it, and your flat molars at the back go to work, grinding and mashing the apple into a soft, pulpy mass. This is mechanical digestion, and it's super important because smaller pieces are much easier for the rest of your system to handle. But wait, there's more happening in there. As you chew, your mouth starts to get watery. That's not just water, it's saliva. You have salivary glands under your tongue and in your cheeks that produce this amazing liquid. Saliva is a true multitasker. First, it moistens the food, making it slippery and easier to swallow. Imagine trying to swallow a dry cracker without it. But saliva is also a chemical warrior. It contains special things called enzymes. One of these enzymes, amylase, immediately starts breaking down complex carbohydrates into simpler sugars. That's right. Chemical digestion begins right here, in your mouth, before you even swallow. Here's a fun fact for you. You produce about 1 to 1.5 liters of saliva every single day. That's enough to fill a couple of large water bottles. This constant flow of saliva not only helps with digestion, but also washes away leftover food particles and fights off germs, helping to keep your teeth and gums healthy. Your tongue also plays a starring role in this part of the show. It's a strong muscle that expertly moves the food around, pushing it between your teeth for a thorough grinding. Once the food is perfectly mashed and mixed with saliva into a soft ball, your tongue pushes it to the back of your throat, ready for the next stage of its journey. Once you swallow, our food ball, now officially called a bolus by scientists, has to get from your throat down to your stomach. It doesn't just fall down like a rock tossed into a well. Gravity helps a little, but the real magic is done by a muscular tube called the esophagus. The esophagus is about 25 centimeters long and connects your pharynx, which is the back of your throat, to your stomach. It's a soft, flexible pipe that sits right behind your windpipe. A special little flap of cartilage called the epiglottis acts like a traffic cop. When you swallow, it cleverly flops down to cover your windpipe, ensuring your food goes down the right tube and not into your lungs. The journey down the esophagus is like a ride on a muscular roller coaster. The walls of the esophagus are made of strong muscles that work in a coordinated, wave-like motion. This process is called peristalsis. Think of squeezing a tube of toothpaste from the bottom to get the paste out at the top. It's a very similar idea. Muscles behind the bolus of food contract and squeeze, while muscles ahead of it relax, creating a path for it to move forward. This muscular wave is so powerful that it can get food to your stomach even if you were to eat while standing on your head. Although I definitely don't recommend trying that experiment at home. The trip down the esophagus is surprisingly quick, usually taking only about 7 to 10 seconds. It's a direct, non-stop express route to the stomach. The inside of the esophagus is lined with a smooth, slippery layer of mucus, which helps the food slide down easily without getting stuck. It's like a water slide for your food. There are no chemicals or enzymes for digestion here. The esophagus has one main job, and it does it perfectly: transportation. At the very bottom of the esophagus, there is a special muscular ring called the lower esophageal sphincter. Think of it as a gatekeeper or a one-way door. This sphincter muscle relaxes to let the food pass into the stomach and then tightens up again to prevent the food and all the powerful stomach acid from splashing back up into the esophagus. Welcome to the stomach. If the mouth was a food processor, the stomach is a high-powered, acid-filled blender. This J-shaped muscular organ is like a stretchy bag that can expand to hold up to a liter or more of food and drink. When our bolus of apple arrives through the esophageal sphincter, the stomach's powerful muscles get to work. The stomach walls begin to contract and relax, churning and mixing the food with incredible force. This physical action, a continuation of mechanical digestion, helps to break the food down into even smaller pieces, turning everything into a thick, soupy liquid. This stomach-made soup has a scientific name chime. But the stomach's power isn't just in its muscles. The inner lining of the stomach is home to millions of tiny gastric glands that produce some very important substances. The most famous of these is hydrochloric acid. This acid is incredibly strong enough to dissolve some metals. But don't worry, your stomach is well protected. It produces a thick layer of mucus to coat its own lining, preventing the acid from digesting the stomach itself. This acid has two main jobs. First, it kills most of the harmful bacteria and viruses that might have hitched a ride on your food, acting as a personal disinfectant. Second, it creates the perfect acidic environment for another powerful enzyme to get to work. That other key player is an enzyme called pepsin. Pepsin's specialty is protein digestion. When food like meat, beans, or cheese enters the acidic stomach, pepsin springs into action and begins to break down the large, complex protein molecules into smaller chains called peptides. So, while carbohydrate digestion started in the mouth, protein digestion gets its big start right here in the stomach. The combination of the churning muscles, the hydrochloric acid, and the pepsin enzyme makes the stomach an incredibly efficient digestive chamber. Our bite of apple, along with anything else you ate, gets thoroughly mixed and liquefied. A fun fact about your stomach is that it grows when it's hungry. No, not the organ itself, but the sounds it makes. Those rumbles, scientifically called borborygmi, happen when the muscles of the stomach and intestines contract on an empty, air-filled space. Food typically spends about 2 to 4 hours in the stomach, being churned and broken down into chyme. Once it reaches the right soupy consistency, another muscular valve at the bottom of the stomach, the pyloric sphincter, opens up just a little bit. It carefully squirts small amounts of the chyme into the next part of our journey, the incredibly long and winding small intestine. The adventure is getting really interesting now. Leaving the churning pot of the stomach, our soupy chyme enters the longest and perhaps most important part of the digestive tract, the small intestine. Don't let the name small fool you. It's only called that because of its diameter, which is about 1 inch. If you were to stretch it out, the small intestine of an adult would be about 6 meters, or 20 feet, long. That's longer than a minivan. It's coiled up neatly inside your abdomen, an incredible feat of natural packaging. This is where the real magic of digestion and absorption happens. The small intestine is the nutrient superhighway, where all the good stuff from our food is finally absorbed into the body. The small intestine is divided into 3 parts: the duodenum, the jejunum, and the ileum. Most of the heavy-duty chemical digestion happens in the very first section, the duodenum. As the chyme enters from the stomach, it gets a chemical cocktail treatment from 2 very important helper organs, the pancreas and the liver. The pancreas squirts in a whole bunch of powerful enzymes that can break down carbohydrates, fats, and proteins all the way. The liver produces a greenish liquid called bile, which is stored in the gallbladder. The gallbladder releases this bile into the duodenum, where it acts like a detergent, breaking up large fat globules into tiny droplets, making it easier for the enzymes to digest them. Now, how does the body actually absorb all these tiny nutrient molecules? The inside wall of the small intestine is not smooth. It's covered in millions of tiny, finger-like projections called villi, and each of those villi is covered in even tinier projections called microvilli. This creates an enormous surface area for absorption. If you could flatten out the entire inner surface of the small intestine, it would cover a tennis court. This massive, velvety surface is incredibly efficient at grabbing onto the digested nutrients, like simple sugars, amino acids, fatty acids, vitamins, and minerals, and passing them through the intestinal wall into the bloodstream. Once in the bloodstream, these nutrients are carried all over the body. It's like a delivery service, dropping off packages of energy and building materials to every single cell. Your muscle cells get energy to help you move, your brain cells get fuel to help you think, and your bone cells get minerals to help you grow strong. The small intestine is so incredibly thorough that by the time the leftover food material reaches the end of this 20-foot journey, about 90% of all the available nutrients have been absorbed. What's left is mostly water, indigestible fiber, like the skin of our apple, and some other waste products. The next and final stop is the large intestine. After its long and winding journey through the small intestine, what's left of our food, mostly water, electrolytes, and indigestible fiber, enters the large intestine. The large intestine is wider than the small intestine, but much shorter, measuring about 1.5 meters or 5 feet in length. It forms an upside-down U shape around the coiled small intestine. Its main job isn't to digest food, as most of that work is already done. Instead, its primary roles are to absorb the remaining water from the indigestible food matter, compact the leftovers into waste, and then store that waste before it leaves the body. It's the recycling and waste management plant of the digestive system. The journey through the large intestine is much slower than in the other parts of the system, taking anywhere from 12 to 48 hours. This slow pace gives the large intestine plenty of time to do its most important job, water absorption. As the leftover material moves through the first part of the large intestine, called the colon, the cells in its lining soak up most of the remaining water and electrolytes, like salt, and return them to the bloodstream. This is a crucial water conservation step for the body. Without the large intestine, we would lose a huge amount of water every day and become dehydrated very quickly. It's a true water-saving champion. Here's a really cool science fact. Your large intestine is home to a massive community of bacteria. So we've followed our bite of apple on an incredible journey from the first crunch in the mouth to the final exit. We've seen it get mashed by teeth, churned by the stomach, zapped with chemicals, and squeezed through miles of tubing. Every step of this process, from the saliva in your mouth to the bacteria in your gut, is perfectly designed to do one thing: unlock the power hidden in your food. Digestion is the fundamental process that turns the outside world, plants and animals we eat, into the very substance of our own bodies. It is, quite literally, what turns food into you. Without this amazing system, eating would be pointless. Think about everything you do in a day. You run, you jump, you learn, you laugh, and you grow. Every single one of these actions requires energy. Digestion is the process that supplies that energy. The carbohydrates from our apple were broken down into glucose, a simple sugar that is the primary fuel for our cells. The proteins from a piece of chicken are broken down into amino acids, which are the building blocks your body uses to build and repair everything from your muscles to your hair. The fats from a slice of avocado provide long-term energy storage and help build cell membranes. Digestion is the key that unlocks all these essential materials. This journey isn't just about energy, it's about life itself. The nutrients absorbed in the small intestine are critical for growth, for repairing a scraped knee, for fighting off a cold, and for keeping your heart beating and your brain thinking.